So remember, they have given us the normal distribution. They have given us the defining parameters, that is the mean and the standard deviation. And then they want us to do something quite easy. They want us to give them the probability of X being less than 3, being less than 3. So the very first thing we shall do in trying to solve this is to come and draw our normal probability bell-shaped curve, which is fully defined by two parameters, the mean, which is 10 here, and the standard deviation, that is 8 there, which is 8 there. So ladies and gentlemen, this time around, they're speaking about us giving them probability of X being less than 3. So being less than 3, first of all, define 3 vis-a-vis the mean. Where is 3? 3 is here. 3. So less than 3. Less than 3, we have less than 3 like that. The area which is on the left-hand side over 3 is what is less than 3. Is what is less than 3. Is what is less than 3. Okay. So ladies and gentlemen, after I've been able to do this, the next thing will be for me to come here and standardize. So the next thing will be for us to come here and standardize, that is get the Z-score. Remember, the formula of Z-score is X minus mu divided by standard deviation. So our Z-score will be equal to X. What is our X? If you look at this very well, our X is any number that is on this X-axis other than the mean. So it must be 3. So 3 minus the mean, U, which is 10, all over the standard deviation, which is 8. So could you kindly give me this figure? What is 3 minus 10 divided by 8? Kindly give me the figure. 3 minus 10 divided by 8 will give us what figure? 3 minus 10 equals, so Denise gives me 0.88. Remember, Z-score can only be in terms of 2 decimal places. Z-score always 2 decimal places. So having gotten that Z-score, the next thing that I'll think about is the entry figure from our table. Is the entry figure from our table. I want to imagine that you guys have your tables. So I have my table here. So what I'm looking for is Z of 0.8. So what I'll do, I'll look for Z, 0.8 here. And then of course, the second decimal place is 8. 8 there, 8 there. So I'll be looking for Z, 0.8. And then of course, on the column side, I'll be looking for 0.08, 0.08. So this Z column, I can see 0.08 is here. I hope you're able to see my cursor. 0.08 is there. And then this other Z column, 0.8, I can see it is here. So I will go with this slowly up to this column of 0.08, slowly. What am I able to see there? I'm able to see 0.31057. For those of you who have got 4 decimal places, it is 0.3106. 0.3106, 0.3106, 0.3106. For those of you who have got 4 decimal places table, it is 0.31, 0 what here? 06, 0.3106. Now, ladies and gentlemen, this is what we call the entry. And remember, when I'm reading my entry, I will have to forget the negative. Negative is not important to us. So the entry here is 0.3106. Once I have my entry very well defined like that, now I need to go to the next area, which is ascertainment of the probability itself. Remember, our probability is represented by the shaded area. Our probability is represented by the shaded area. So the shaded area, I can see it is this area. And whatever area that you have read here, given by the entry, is the area between the 2 variables that you subtracted. The area between 3 and what here? 10, between this and this. Between the 2 variables you subtracted. But fortunately, we know that this total area on the left-hand side is 0.5. The total area on the left, the whole of it is 0.5. So if you tell me that this is 0.3106, I'll easily give you this other area because the 2 must always add up to what here? 0.5. And therefore, our probability will be equal to our shaded area, which will be 0.5 minus, which will be 0.5 total shaded area, which will be, so remember, after we did get that entry of 0.3106, we said the 0.3106 represents the area between 3 and the 10, the two values that you subtracted, 3 and 10, the two values that you subtracted. And we happen to be knowing that our total area on the left-hand side, is equal to 0.5 because the normal distribution is normally, ladies and gentlemen, symmetrical about the mean. So this area here is 0.5. And therefore, the probability will be equal to the shaded area, which will be given that the two must add up to 0.5. So the shaded area will be 0.5 minus this. So 0.5 minus 0.3106, which somebody was able to get. So what is 0.5 minus 0.3106? Can somebody help me out here? Somebody please help me out here. When you say 0.5 minus 0.3106, what are you able to get there, somebody? Please, 0.1894. 0.1894. And you saw some students who were able, like Edward was able to get this figure of 0.1894. 0.1894. 0.1894. 0.1894.